Okay, today we're going to talk about a line of best fit for a scatter plot. Now, the whole purpose of scatter plots is to kind of look for trends in data and use those trends to make predictions. So one of the ways that you can do that is by creating a line of best fit. Now, a line of best fit is a straight line that models the data. Now, it may go through one point, a few of the points on the graph, or it could possibly go through none of the points, and that is perfectly fine. The line is meant to kind of model where the dots are. So let's take a look at what a line of best fit looks like and what it does not look like. So here we have 4 of the same graph, and we're going to look at what is considered a line of best fit and why. So A is not a line of best fit because that straight line that's drawn is really above most of the data. It's touching kind of 2 points on the graph, but all the other points are below that line. So it's not really modeling the data, it would be kind of overshooting it because everything on that line is above the true data. So that is not a line of best fit. Now B is not a line of best fit because it's kind of undershooting the data. All of the dots are kind of higher than what the line is predicting. So that is not a line of best fit. For C, we can see that the line is kind of going through the middle of the clumps of dots. There are some dots that are below it and some that are right on it and a few that are above it. So this is a line of best fit. You notice that a couple of the dots look like they're right on it, but again, not all the time do the dots have to be on the line. And then for D, you can clearly see that that's not a line of best fit. This line is not even going in the direction of the data. All right, so here we've got a graph and the line of best fit has been drawn in. We can see that it's kind of going through the middle of the clumps of dots. And there are a few points that are directly on that line of best fit, but for the most part, the dots are just near it. This would probably have a correlation coefficient of probably 0.8, which means that this line that we've drawn through those dots would be a pretty good model or predictor of what would happen. Today we're going to look at writing an equation for the line of best fit and what that equation means. So to write an equation for a line of best fit, what we need to do is identify 2 points on the line. Now we can see that this dot right here is on the line, but I'd have to make some estimations about where it would cost. So instead of using a dot that's on the line, I'm going to pick my own points. So I can see that right here, the graph is going through the grid line at a perfect cross. And then I can see it's doing that down here again too. So I'm going to use these points for my line of best fit. So I'll make those in red so we can really see. I'm going to use that value and this value. And I'm going to record how much it is. So it's 535 and 1.75. And so to write an equation, we need to find our slope. And again, that's the change in y over the change in x. So let's look at how the y value changed. It went from 535 down to 505. So the y value changed by going down 0.30. And the x value went from 1.75 to 3.5. So it changed by a positive 1.75. All right, now you can grab your calculator and do that division. So on my calculator, I'm going to do negative 0.3 divided by 1.75. And that tells me it's negative 0.17. Now, a lot of times kids have a hard time understanding what this means. Now on my calculator, I got a longer number. I just rounded it to 2 decimal places. So this negative 0.17, we have to look at the label. So this was money in boxes. So when I do this division, it's going to tell me how much money per box. That's what that division tells us. It's a unit rate. So it's telling me that it drops 17 cents for every box I order. So that's what that would mean. Now to write our equation, we're going to say y equals negative 0.17x plus b. Now that's our y-intercept. And I'm going to use one of our points. I will use this one. So the y value was $5.05. And the x value was 3.5. And I'm going to solve to find my y-intercept, just like we did last week in those practice problems. It just happens that these numbers are a little bit messier. All right, so we're going to do negative 0.17 times 3.5, and we get negative 0.595. And I'm going to add to isolate the variable to get b alone. So 5.05 plus 0.595 is 5.645. That's my y-intercept. Now it's money, so we could really round it to the tens place value and have it be 5.65. And then writing our equation, we would say negative 0.17x plus 5.65. So it looks like the cost of a box costs $5.65, and it goes down 17 cents for every box that I order.